Hello everyone. Today I will be discussing how prenatal exposure to fine particulate matter PM2.5 can influence the development of asthma in children. This presentation is based on recent research, including a large Danish cohort study. Asthma affects many children worldwide and is a leading cause of health issues in youth. Growing evidence suggests that environmental factors, especially air pollution, play a significant role. PM2.5 tiny particles from sources like vehicle exhaust and wildfires, is widespread in our environment. Because these particles are so small, they can penetrate deep into the lungs and even pass through the placenta during pregnancy, potentially impacting fetal development. The main question guiding this research is whether exposure to PM2.5 during pregnancy increases the likelihood of a child developing asthma. To explore this, I reviewed five major cohort studies, including a comprehensive nationwide Danish study, to understand the relationship over different populations and environments. Modern studies now use sophisticated methods to measure prenatal air pollution exposure. Instead of just relying on a nearest air monitor, researchers combine satellite data, land use information, and atmospheric models. This approach provides a detailed estimate of how much pollution each mother was exposed to at her residence during pregnancy, which improves the accuracy of linking air pollution to health outcomes. The Danish study, involving over a million children, found that every 2.4 micrograms per cubic meter increase in PM2.5 exposure during pregnancy, the risk of childhood asthma increased by about 6%. This strong association persisted even after adjusting for socioeconomic factors and other pollutants, highlighting that even small increases in pollution can have significant health effects. Research shows that the timing of exposure matters. Multiple studies identified a critical window during mid-pregnancy, specifically between weeks 16 and 25, when the developing youngs are most vulnerable. Exposure during this period has been linked to a higher likelihood of asthma later in childhood. The lung structures and airways are rapidly forming at this stage, so disruption here can have lasting effects. Even modest increases in prenatal PM2.5 levels can lead to thousands of additional asthma cases. For example, reducing the average pollution levels in Denmark by just 1 microgram per cubic meter could prevent over 1,000 cases. In countries like China, where pollution levels are much higher, the risk increases even more, emphasizing the global importance of controlling air pollution. Not all children are equally affected. Boys tend to be more vulnerable, possibly because their lungs develop differently. Maternal stress during pregnancy also amplifies the risk. Stressed mothers exposed to higher pollution have children with a greater chance of developing asthma. Additionally, continued pollution exposure after birth further increases the risk, showing that both prenatal and early postnatal environments are important. So, how does pollution cause asthma? The particles can trigger inflammation and oxidative stress in the placenta and developing lungs, interfering with normal lung growth and immune development. These changes can lead to smaller airways and an immune system more prone to allergic reactions, ultimately increasing asthma risk. Given this evidence, reducing air pollution during pregnancy should be a priority. Policies to cut emissions, providing indoor air filters for pregnant women in high exposure areas, and supporting families facing social stressors can help prevent childhood asthma. Early intervention can make a real difference in children's health outcomes. While these studies are strong, they have limitations. Most rely on record-based diagnosis rather than objective lung function tests. Also, indoor exposures like cooking smoke aren't always measured. Future research should include biological markers and personal monitors to better understand the biological pathways and improve exposure estimates. In conclusion, evidence shows that prenatal exposure to PM2.5 significantly increases the risk of asthma in children, especially during sensitive periods of lung development. Addressing air pollution and supporting pregnant women can help reduce this burden and promote healthier futures for children.